Southern Illinois University's Aquaculture Research Lab and Illinois-Indiana Sea Grant presents the Larval Yellow Perch Culture Video Guide. Module 5, Stocking Larval Rearing Tanks. Prior to transferring yellow perch larvae from the incubator to the larval rearing tanks, you will want to make sure larvae are ready to stock. To do this, take a beaker of larvae and provide with rotifers. Observe the larvae. A majority should be free swimming and ingesting rotifers before stocking. When the larval rearing system is up and running and ready to be stocked, gently collect larvae from the egg incubation system and place in an aerated container. If you recall from Module 3, the larval catchment tanks are lined with mesh bags. The mesh bags are gently lifted out of the water and quickly but gently transferred into an aerated container. From this container, larvae are enumerated. By collecting and counting the number of fish in 6 or more samples, you will be able to come up with an estimate on how many fish you have in the container. Fill a 1-liter beaker with water and larvae from the container and gently transfer larvae to one larval rearing tank. Add 1 liter of larvae to larval rearing tanks one at a time until all tanks have received 1 liter of larvae. Repeat until all larvae have been transferred or you have reached maximum stocking densities. Record how many 1-liter samples were added to each larval rearing tank. By taking the number of larvae in 1-liter beaker times the number of beakers added to the larval rearing tank, you can come up with an estimate of how many fish were stocked into each tank by using the average number of larvae. For example, if the average number of larvae in a 10 milliliter sample is 10, you will multiply 10 by 100 to get an estimate of 1,000 larvae per 1-liter beaker. If you put 2 beakers or 2 liters into larval rearing tank number 1, you will then multiply the number of larvae in 1 liter by the number of liters added, which in this case is 1,000 times 2, giving you an estimate of 2,000 larvae that were stocked in tank 1. The desired larval stocking density for rearing tanks should be between 50 to 100 larvae per liter of culture water. It is recommended to figure out roughly how many liters of larvae to add to each tank prior to stocking to prevent overstocking. Converting tank volume from gallons to liters. There are 3.785 liters in 1 gallon. To convert your culture tank volume from gallons to liters, multiply the number of gallons by 3.785. For example, for a larval rearing tank that holds 74 gallons of water, multiply 74 gallons by 3.785 liters per gallon to get 280 liters. Next, calculate the volume of larvae to add to each tank. For example, if your desired minimum stocking rate is 50 larvae per liter of rearing water, your rearing tank volume is 280 liters, and you have estimated to have 1,000 larvae per 1-liter beaker, you will take the stocking density of 50 larvae per 1 liter of water, multiply that by 280 liters, and then divide by 1,000 larvae per 1 liter sample to learn that you would need to stock your tank with a minimum of 14 1-liter beakers of larvae to hit your minimum desired stocking density. Since the maximum stocking density is 100 larvae per 1 liter of tank water, which is twice the amount of the minimum stocking density, you can either repeat the calculation with the maximum stocking density rate or simply double the answer from the previous calculation. It is important to mention that the stocking container that holds all of the larvae should be small enough to condense them and well aerated for even distribution throughout the water column. Otherwise, there is a risk that each beaker will generate different larvae counts. As less larvae are distributed, it may be necessary to recount the number of larvae. Once all larvae have been distributed, add salt and clay to the system. In an additional tank that has no larvae, fill the tank with water and treat with sodium thiosulfate if necessary to remove chlorine. Add finely ground ball clay. The preferred clay for Percid larval culture is Old Kentucky Ball Clay number 4. Add a small amount at a time until turbidity is roughly 15 NTUs. Allow the clay to move throughout the system. This will increase the turbidity in the larval rearing tanks. As clay settles out of the clay concentration tank, add more or stir to resuspend the clay. Keep water constantly turbid during the larval phase. When using marine live food, such as certain species of Rotifers or Artemia, add a small amount of salt to the system to raise the salinity to approximately 1.5 to 2 part per thousand. This will allow the live food to stay swimming in the water column longer. Salinity calculators can be very helpful when deciding how much salt needs to be added to bring the system water up to the desired salinity. Read the North Central Regional Aquaculture Center fact sheet, Use and Application of Salt in Aquaculture, to learn how to figure out how much salt to add to the system. A link to the fact sheet can be found below in the video description.